Welcome to today's video on how to use Facebook data to calculate population density. So this is we're going to be using ArcGIS Desktop, and I'm going to run us through quickly. So I'm going to show you now where you can download the data we're going to be using. So over to your browser, you can just search this on your Google search, and this is the website that we are going to be opening. So data for good, Facebook data, and you just scroll down. Okay, data access. This is a public data set, and this is the link where you download that data. Okay, so depending on the country of interest, you can actually search for it and get it downloaded. For me, I am working with the data for Nigeria, so I have the data already in my system. Okay, so let's head over back to our ArcGIS Desktop. So I'm going to be pulling in the data now. All right, so this is the one for Nigeria, and I'm going to show something shortly right now. Okay, so before now, when we talk about population density, we are quite familiar with something of this nature. Just watch. Okay, all right, something of this nature where we simply run something like this, and we can say the places where the colors are deeper have the highest population density. All right, and the places that have the lighter colors have lesser population density. And this is shown in the legend, in the layers here, but this is going to appear in the legend if we export the map. And so let's say, for instance, you want to calculate the population, because these two appears to be the two administrative sections in the state with the highest population density. Now, how can we see the distribution of this density? How can we see? We don't have we are just used to this method of calculating the density. So I'm going to show us how to use Facebook data, because of course Facebook data to a good extent has a good representation of the population. Most people are on Facebook, especially for this state, and the distribution of that number can be used to calculate the population density. So that's what I'm going to be showing us today. All right, quickly, so let's just export that local government. So this is Akwa Ibom State, and this selected polygon is a local government, and it is called Uyo. So I'm going to be exporting it out so that we can work on it independently. All right, so here quickly we can select everything, but we are working with selected feature, and I'm going to be selecting where I want it to be stored. Okay, I want it to be stored here, so I'm just going to call it Uyo LGA. I prefer to write this way, Uyo LGA. Do you want to add the spotted data to the map as a layer? Yes, perfect. Let me remove the selection. Okay, so we're good. So this is it. For now, I will untick this, and let's work with this rather. Yes, so this is what we have. Now, looking at the Facebook data, let me go to where we are. I had converted it from CSV to a shapefile layer. This was so that I would be able to work with the file much more easily. So watch what I'm going to do now. I'm importing it, and I'm going to run selection by location to select the points that fall in the local government and work with those ones only. Okay, so okay, great. So this is it, and our source layer is already selected here for us. Okay, so let's just wait as it selects for us. Okay, I think we have our selection now. So we're going to export our selection into a new shapefile layer, just as we did for your local government. So come to data, export data, and we are exporting just the selected feature. So I'm calling this Facebook data point. Great. Okay, and there we go. It's almost done. Okay. Do you want to add the exported data to the map as a layer? Yes. Okay, great. So I don't think we need this one anymore. Now it's slow because the data is much, it's huge. Okay, so we don't need this anymore. And we can practically remove it. All right, great. So looking at these point data now, we are moving forward and we can actually work with this. Okay, so when we talk about density is calculated as, in this context, the points all over the area is going to give us the density of the population. How populated, what is the distribution of the points? How populated is it? So the density is going to give us that value. Okay, so quickly we will need to, since this is going to involve some level of measurement, we need to export this we need to project the projection. It's actually in a geographic coordinate system. So we have to change it to a projected coordinate system. So quickly, I'm going to be opening my toolbox and I'm going to run the projection. All right, so so we head over to the toolbox, Add Toolbox, Data Management Tools, Projections and Transformation. We're actually projecting it. And we are imputing our data set already. We go local government. Okay, and all right. So our output, we are going to select where we want it to be stored. So I'm going to call it your LGA projected rather. And I'm going to select which coordinate system I want to use. So originally the file is in this coordinate system, which is a geographic coordinate system, and I'm changing it to a projected coordinate system. Okay, UTM is on 32 north. Okay, perfect. I think we can run it now. So our file is successful, and we are going to add it in. Here it is. Oh, it came in almost the same color as the old one, so we don't need this anymore. We are taking it out. All right, so now we have our point and our projected polygon shapefile. and we need to do something with the polygon now. Just watch. I'm going to bring in so over to your search, just type this, and we want to generate tessellations for this polygon shapefile, and this is going to enable us to calculate the density, the population density of this local government. Okay, so let's okay, I just want to quickly rename this now. Okay, extent. I wanted to pick this extent, and notice you can actually do it for different shapes, but I love to use hexagon. And for this now, I think I want to use square kilometers, and I want it to be 2. So the size of each hexagon is going to be 2 square kilometers. Sorry, 2 square kilometers. And all right, the spatial reference has already been selected for us. I think we can run this now. Okay, wow, so we have this now. All right, it's on top of this. So notice, okay, let me give it another color so that it will become easy for us to relate with it. Yeah, so this is it. Let me just drag this over it. Okay, so there we go. So just as we did for the point, I'm going to be using the selection by location to select what we need to select and export them into a new shapefile layer. Okay, so this is actually going to be, yes, this is going to be our source layer. This, and let's run the selection. Okay, so we have the selection here already. And what are we exporting? We're exporting this. We are exporting this now. So we're exporting the selected hexagons here. Just follow through. And we are exporting the selected feature. So let me call it test. Okay, very importantly, we need to give the names we can recognize. All right, so do you want to add exported data to the map as a layer? Yes. Okay, let's select it here. So apparently we don't need this anymore. Taking it off. So looking at, so we have this, we are going somewhere. So right now I want to trim off these parts that we do not need. So quickly I'll go through the job processing. So I want to use the clip tool to clip off what we do not need. So what we're imputing, video test, and our clip feature will be this. Okay, so I'm selecting where we want it to be stored. So I'm going to call it video test clip. How you name these files are very important so that you don't get confused. So we are running the clip, and we have our clip file, and it has been added automatically. So at this point we don't need this anymore. So we are heading somewhere. For now we won't even need this. Yes, we won't even need this. So we have this. Let me just put it below. So now we have this and this. we're going somewhere. All right, so I just want to show us what's in the attribute table. Oh, it's actually quite blank. Okay, so we are going to create some columns soon. So now let's do a simple analysis now. So we want to calculate the number of points that are in each polygon. Now notice, let me untick this now. Notice we have different polygons and all of that, and we want to calculate how many of the points are falling into these polygons. So we are going to be using spatial joins. So quickly, let's search for spatial joins. Okay, so this is the one we are going to use, spatial join analysis tool. So what's our target feature? Can you guess? All right, our target feature is going to be, let me see, it's going to be this. Then our join feature is going to be this, the point. And let's select where we want it to be stored. Okay, special. There we go. Okay, our work is complete. So let's check. It has been added here automatically for us. So here it is. It has been added here for us, and we won't need this anymore. So let's just put it aside. So now this is what we're working with. So let's check what happened. Okay, so opening the attribute table, we can see the join count. So for each of these points, for each of the polygons, we can see we can actually see. For example, the one I just selected, there's just 1 point in it, and all. Where would this one be? Okay, so it looks like there's a duplicate point here. There's a point sitting on a point. Because of the resolution, we can't really see it, but if we zoom in, we will see that there are 2 points right there. Okay, so we have many others, and this is the number of points in those hexagons and polygons. Okay, so quickly, how we calculate density, we calculate the number over the area, the number of points over the area. So we are going to be calculating for density now. So we need area, we need a column that will carry the area of the polygons. So we are creating an additional field, and let's call it area. It's going to give us decimal, so that's double. And quickly, let's calculate it using calculate geometry. Okay, now this is why we projected it to a projected coordinate system, because with the geographic coordinate system you can't calculate area, perimeter, and perimeter. So we needed to project it to a projected coordinate system so that we could use it to calculate area and perimeter. So what I want to calculate is going to be square kilometers. All right, and there we go. Okay, don't worry about that. So we have the area for these points being calculated. All right, let's see. So for this polygon, that's the area in square kilometer. That's the area square kilometer. Okay, so now we have the area and we have the point, the count, the joint count, the point count. So now we need to create another additional column for density. So just watch. We're adding field. Let's call it density. It's also going to be double because it's going to be in decimal. So quickly, we are here. Decimal. So we're going to be using the field calculator. So density is equal to joint count divided by area. Okay, and yes, we have our data. Perfect. So we have the joint count. We have the joint count. We have the area, and now we have the density. Now we can actually run visualizations now. So quickly close it. At this point, we won't be needing this anymore. We have all we need to work with. So quickly, let's go and run what we need to run. There we go. Under symbology, under quantities. So let's select our density. Okay, coming over to classify. Doesn't really matter what you choose now, but I like to use natural breaks, and I like this to be 4. Right, great. You can actually edit your label how you want it to appear in the legend. You can put this at 0. Let me just quickly. Okay, let me quickly run this. Okay, this is just test work. Just to make everything beautiful. Okay, I think we're almost done. And there we go. So we are good. Actually, you can choose the color you want. I think this is the color I have here. Great. So wow, so this is it. So we can see the densely populated, the highly populated, the less densely populated, and all. So just as we edited it at the symbology section, you can even change this to high and low and keep these spaces blank. So this is what we have. And to make it even more interesting, I want to remove these outlines. I could just leave it at 0. Just watch what's going to happen. Okay, so let's just give it a simple boundary by adding one of this, making it no color. I think this is just good for now. Yes, we've given it a boundary. It makes more sense this way. So this is our map of Uyo local government of Akwa Ibom State, Nigeria, showing us the population distribution in the local government. And truly, this makes a lot of sense, because this is where the population really is in the state. If you check the satellite image, here is highly is a residential, industrial, all the traffics, all the connection routes, network analysis, heavy economic activities in the state take place here. All right. If I bring in the base map now from OpenStreetMap, you will see exactly that here is highly developed. Yeah, and there is a town down here. All right. So this is how a simple way. So if you want to overlay other data, maybe roads, schools, hotels, hospitals, you can actually fade this color out. You can make it more transparent and put it as a background, right? So simply you just come to display, you increase the transparency. All right, so you're good. So let's just simply export. Let's finish up the work and we'll be good. I don't think I like this frame. Let me change it. I think I like this one. This is good because we always like this rather. Okay. So to center my work, I just simply do zoom to layer. And I'm good. Okay. I can still increase it further if I want to. And let me just quickly add two basic things. Okay. I'm going to rename them later. I like to put this. Okay, quickly, I think we need to edit this now. It will show when we edit it. Did I spell that well? Great. I think I can actually remove this. I don't need that. I can rename this to LGA boundary. I think that makes sense now. And very importantly is your north arrow. Your map is not complete without a north arrow. I think this height is just perfect. And we're good. So this is the end of this training, how to use Facebook data to show population density. This cuts through, this zeroes in on any location and shows us the visualization, which we can now use to tell areas that are highly populated and areas that are lowly densely populated. So if you come to the end of the video, I'm sure you've learned something. If you want to see more of my videos, please like this video and subscribe to my channel. Thank you.